Well, how to fix your microwave. Let me first tell you how they work, so you'll understand them and won't be scared of them. At the back, on the little sticker of information, it says 2450 megahertz. That's the frequency of the output of the radio waves that the magnetron, which is over here, makes that cooks the food. Microwaves don't make any type of nuclear radiation or anything like that. All they are is like a radio transmitter that makes radio waves. The radio wave frequency that they produce happens to be the natural frequency that water molecules like to vibrate at. So it increases the amplitude of the natural vibration of the molecules to a point where there's a lot of friction created while they're rubbing together, and that heats the water or heats anything else that you put in there that has moisture in it or fats in it. Simple as that. There's no residual radiation when you shut them off, and unless your door is very loose and floppy, which of course generally they aren't, there's no way microwaves can escape. The little tiny holes in the door are too small for the size of the waveform of a microwave to escape through that hole, so that's why you can look in and not get cooked at the same time. Since microwaves are powerful radio energy of the electromagnetic spectrum, they can create voltage or electricity. The box is made out of metal, but the waves reflect off smooth surfaces and nothing happens. The sides do not become charged. In the top of your microwave, except for this one that's unusual, usually is a plastic panel, and in there is an aluminum propeller that's usually blown by air, or a little tiny motor moves it slowly, and that's called the stirrer fan. The stirrer fan distributes the microwaves around the oven more evenly so that you don't get burnt spots on your food and uncooked spots on the other. This one is using a side panel to distribute the microwaves inside the box, with this plastic part here. There's door latches, and inside the holes is several safety switches. They're set up in such a way that if you stick something in the hole, the microwave will not allow you to turn it on with the door open. That's a good idea. Now, I've just garbage picked this microwave because my son wants it for his apartment. He's moving out. And this one's got the crazy little screws with a Torx shape on them and a little pin sticking out the middle that prevents you from using an ordinary screwdriver to open them. Well, you give each one a tap with a hammer, not very hard. Get a small flat ordinary screwdriver, stick it in, it goes beside the pin. See, now I can unscrew it. You don't need to have that special tool. What a redneck genius invention, a flat screwdriver. Well, that's it. This is the magnetron. It produces the radio waves. There's the transformer. It takes 110 volts coming in, and it has an output of about 1500 volts. It sends that power through that capacitor and then through that little diode that's right here. Diode works like a one-way valve. What that causes is a loop circuit, and the frequency keeps chasing itself around, and that's how you make 2450 millihertz. Over here you just have an ordinary circuit board, and the electric switch that turns it off and on is called a relay, and that's this little thing right here. So when you push start, you hear click, sends the power to the transformer. Of course, you have to have a fan that cools the magnetron. Magnetrons are only 50% efficient at creating energy. If your microwave uses 400 watts, if your microwave uses 1400 watts of energy, it probably puts out about 700 watts of output power. These are the cooling fins for the magnetron. Always check that your back vent here is clean. It often gets sticky from grease from the nearby oven or stovetop, and then dust sticks to that and clogs these holes. Then your magnetron overheats, and that can blow your fuse. This microwave happens to have its fuse inside this little capsule. They just look like the old-fashioned car fuses that used to be glass, except microwave fuses, as you can see inside, are made of ceramic, so you can't tell by looking at them if they're blown. Most of the fuses are actually here where the cord comes in. If your microwave is dead when you plug it in, it's probably the fuse. Now, only 50% of the time when your microwave dies is it actually the cause of a defective fuse. Fuses get old and tired on these machines, there's a lot of juice goes through them, and they do burn out for no reason. But they also burn out if your magnetron overheats, or if you put a lot of metal things in there and it arcs too much, or if your transformer shorts out, or if your diode shorts out, which happens sometimes. And actually, most common reason the fuses blow is because your magnetron shorts out. If your magnetron is shorted out, then of course it's no good, and that can be another reason why that diode shorted out. All you do is unplug it, and while it's unplugged and you've got a good fuse in there, if you plug the microwave in and see if the fuse blows, and the fuse doesn't blow, but it blew before, well, then you know you've got a shorted magnetron. If the fuse still blows when you plug it in, unplug the diode. If it still blows after that, then you've got a shorted transformer. Now to tell you about all those scary rumors about microwaves, because some of them are true. Microwaves, like old picture tubes in television, store a charge. This capacitor stores a hell of a charge, 1500 volts, and when you touch the terminals, you can get a hell of a shock even up to 10 minutes after you plug your microwave in. Modern microwaves had a bleeding resistor that's built into the capacitor that goes across the two terminals, so that shortly after you shut it off, the resistor bleeds out the residual voltage in there. Old microwaves have a bigger capacitor and no bleed resistor, so they for sure store a charge for like 10 minutes. I have several times in the past burnt holes right through the back of my hand. I mean, it doesn't just shock you, it's the worst shock you ever had, and it really does burn holes right through your skin. You can smell the burnt flesh. You'll never forget it. It hurts like a week. Now, another most common thing that goes wrong with microwaves is burnt door switches. You can't actually tell when they're burnt out by looking at them, but sometimes you get a clue by the connector plugged into one of the door switches looks a little brown or toasty. That switch is very likely burnt. Sometimes when you push the little button on the micro switch, it doesn't go click. It should click every time you push it. That means it's a bad switch also. The door switches from any microwave oven, they're all the same, so you can easily swap parts. They're easy to get from the garbage. Another very common problem is electronic control problems in the circuit board. Well, that's not likely you'll be able to fix that. So if you have another circuit board exactly the same, that'll solve your problem. If you don't, use the microwave for parts, because the circuit board costs just as much as the whole microwave if you had to buy it. Now, this microwave has a dark terminal on the spade connector that fed the magnetron, so that's a clue that we could have a shorted magnetron, or a fried one at least, that doesn't work. When you turn the microwave on and it's supposed to start working, it makes a little sound that you can tell that it's working without even putting water in it. It first just has a gentle hum, then all of a sudden this part goes bzzz, then you know it's starting to work. When you take a magnetron out of a microwave, this is what it looks like. The cooling fins, two powerful ceramic magnets, which make great things to play with if you like playing with magnets. And this is the antenna that radiates the microwaves, and that little brass gauzy looking thing is the ground and the seal, like the gasket when you install it. If you peel off that cover, inside there is a great big transistor and two coils of copper wire which help produce the frequency. This is a thermal cutout switch, so that if the air is blocked coming in and your fins get too hot, this switch will shut off for a little while and then turn back on again and allow the microwave to keep producing, energy. All microwave magnetron systems like you see here are all wired identically. So you learn one, you've learned them all. The least likely part to go bad in a microwave is the capacitor. The most likely part is the magnetron. The second most likely is a diode, and third most likely is a transformer. Transformers are fairly interchangeable too. You just got to match the power ratings on the microwave, and then that will work. So long as you can mount them, sometimes you have to drill different holes. Magnetrons always have a number, a 2M number. This is a 2M218. That identifies the model of magnetron it is. You don't exactly have to match the 2M number. you do have to match how they mount. Some have mounting tabs, some have little bolts on them, some are held in by little tabs that are bent over here. You know, some have different positions which side the terminals are coming out. So it's a matter of matching how they fit more so than matching their numbers. But of course, outputs, so if you do get the number close, at least you know your output will be the same and match the transformer that goes with it. To test your diode that I've just removed, you can see the electronic picture of it. The schematic is an arrow and a flat. You set your meter to ohms and touch your terminals across the two leads. When you have the polarity in one way, you should get no reading on your meter. When you flip the leads over, since a diode works like a one-way valve, you should get a reading on your meter. Doesn't matter what it is, so long as it's a different reading than the one before. And I'm not getting one, so this appears to have a bad diode. Diodes blow in two different ways. They blow open circuit, or they more commonly blow closed circuit, which means shorted. And that's one of the things that blows your fuses. Here's a better look at a few of the parts. The capacitor. There's no polarity on the capacitor, so it doesn't matter which way you hook the terminals up. You can't go wrong. That's what a micro switch looks like. There's the little click button. It has to click or it's bad. And you have to, of course, test the terminals with your ohm meter and push the button and see if it's a good one, you know, see if it makes a continuity or makes no continuity when you goes off. And this ceramic fuse, which of course you can't tell if it's burnt unless you test continuity on your meter too. Never use a glass car fuse. Since I've got a bunch of spare parts, I just got done changing that defective diode, so now let's try this beast out. It's 100% safe to run a microwave with the cover off. Nothing escapes. Of course, just don't touch any of the live wires. And away she goes. I can see the steam pouring out right now. And she's toasty. Simple as that. A no-cost redneck repair. Gotta love it. I've even got a whole pile of spare magnetrons, just in case another one comes along. I'm also an expert at fixing refrigeration and air conditioning, so I'll soon make a video on that too. And now the final and most important safety tip. Get a pair of needle nose pliers or a jumper wire, and whenever you're working on your microwave, make sure it's unplugged. And if you're not sure if it's stored to charge or not, what you have to do is find the two terminals of the capacitor and make sure you make metal to metal contact and use your insulated needle nose pliers and short the capacitor out when it's turned off. This does not hurt the capacitor whatsoever, and you're guaranteed nothing else in there will shock you, so you can safely work without worry. So you can live another day to have another beer, because that's what counts.